Good morning. Good morning, everybody. Namaskar. Million to power million. Good morning to everyone. This is Yasura Singh speaking from Bharat, India on this day, March 17, 2022, Thursday, 4:17 a.m. मैं सूरज सिंह भारत इंडिया से बोल रहा हूँ, सिविल इंजीनियर। आज मार्च 17, 2022, 4:17 बैक टू यू अबाउट talk, quality coordination talk. As usual, talk about quality is part of our life, and my email is suraj_engineer@yahoo.co.uk, and my certification is this: professional engineer certification Pramar Patra, professional engineer, international professional engineer, and chartered engineer India, fellow institution of engineers, FI is called, quality file, coordination file, and Japan's specifications of concrete is very important for this time. And of course we can say that we have to discuss about this. Title of talk is quality coordination and quality, engineering projects, engineers who are reliable, of course communication is sandwiched, and concrete, civil engineering works and contracts, and if some safety and you can say disputes, etc., construction methods. This is an important time, and we have to be very careful about this issue. And I close this certificates, chartered engineer as well as fellow. And now important files are here. Issue of quality, that is very important. Quality coordination, issue of quality, issue of coordination. First we discuss a little on this and then move on to concrete file, which is intensive talk today. Quality, it is important or it's not important. We have a duty to decide what we have to do, how we have to do, what can we do. All these are important issues that we should be serious about. It's easy to say, saying is always easy, but achieving is very important one. We can say, okay, I will do it sometimes, but can we do it? That's the point of view. Speaking, I'm not really interested in speaking as if I speak when I do something, that's fine, that's called explanation. If we can claim only, if we keep on claiming we have done it, we are doing that, and with nothing at all, then that's called only talk, no, not work. We have to understand quality and coordination in real world, not in debates or not only statements. Statements do not have any meaning if these are not transformed into reality. And quality and coordination are those domain, I call them domain because though it is not formal domain but practical domains. In engineering education we are not taught that, that's true, and engineering cannot teach it because it can teach only first when it must have some subject or some syllabi. If it doesn't have that, we cannot do that. Therefore it's very important that we must understand this point, and if we don't understand this point we cannot do anything. So I say quality and coordination, which domains have been sleeping because we are sleeping. We have to stop sleeping. We have to keep ourselves minds and eyes open. Eyes we have not closed, but minds we have closed. WILL, will we have closed. Or you can say approach toward works we have changed, or this is defective. There are so many reasons for that. You know all them. Carelessness, ignorance. Why to worry about this? Do as it is, no problem. It goes on, no problem. Who bothers, no problem. We can do it, no problem. Chalta hai. Very dangerous phrases we use in life. But one point we have to keep in mind. We have to compare every work as if we think of our body. Tell me one person who wants to live sick, who wants to stay sick, who can think or who can expect that one should be sick. Nobody will say, I want to be sick. But people get sick. And there can be whatever reason for that. I don't say anything. But it is very difficult to work properly. You know, there are two ways. One is construction and one is destruction. Construction, I'm not talking of construction of civil, I'm talking general. Construction is very difficult, it is time consuming, it is efforts consuming. While to break something is very easy. It will take just a fraction of time that is required for construction to break. A fraction of time, maybe 2%, 1%, 0.5%. And construction takes a lot of time. It's a fact of life. If you want to construct a building, it may take 1 year, 2 years for a building construction. But if you want to break same building, you will take maybe 1 week, 2 weeks maximum to break it. If it is RCC or if it's ordinary building, you can break in 3 or 4 days, no issue. Or if it's only small one, maybe one day you can bring JVC and break it. But that same JVC cannot make it. Think of same machine which you say bulldoze it, you can bulldoze it. But can you use same bulldozing effect to construct that? That is what I want to say. It is very difficult to construct. Think of that power which we call superpower or God. That power constructed this earth for us. That power constructed this solar system for us. That power constructed whole universe for us. We may be whatever level of engineers and scientists. Can we contemplate really? Can we understand how it has been done? It was done and still it's working, it's doing its job. It has been still successfully working and nobody knows how. System is known, that's fine, but how is something beyond imagination? I cannot think how you can even construct a small earth or solar system physically. Cannot. That's why I say sometimes we have to dream in that way. We have to think in that way. If I cannot construct anything as such, what right I have got to break it? And I don't know why humanity is having certain degree of weakness. They always think to kill others and break others. And those people who are interested, who are destined towards construction of this world, or development of this world, and if these people see people are killing each other, people are breaking buildings, people are breaking everything, even people break hospitals, schools, buildings, what they think about, how they feel about. Really, it is very big weakness of humanity that we forget that we did not do it. We have no right to break something, but we break. Same thing, when we do something, we have to think about importance of quality that we define ourselves, nobody else defines. Importance of quality, importance of standards, and how best we can do it. Every time we should think that way, because it is always good to do something in a constructive way, not in a destructive way. And that's why I am inclined always towards quality, coordination, communication, specifications, reliability. And whatever we do in status of concrete. I mean concrete not as material, but as a kind of concept. It should be concrete standard, solid standard, powerful standard, durable standard, because concrete is always durable. Even if it is not to standard, it would work to some extent. We use bricks in houses construction, we use block work in houses construction, we use concrete in houses construction, steel in housing constructions. What we don't use? All these materials are not easy, first of all, to produce. How can you produce bricks if you don't have clay soil? Can you produce? You cannot produce. From where does clay come? You have to think of. It comes from soil. It comes from earth crust. Same we produce concrete. using ingredients like stone chips, sand, or aggregate like fine sand, like dust, water, cement. From where these come? These come from nature. So we should think that way. We do not produce anything and we boost everything. My dear friends, what I am saying, if you experience yourself in life, it's very difficult to work properly. It's very difficult to work strongly because quality demands you something. You yourself may say, oh my God, I'm not doing quality work. You can yourself examine your work. You would say, no, I've not done right. Maybe you sell that work, that's different, but your internal soul, internal power say, no, you have not done justice to yourself. And that's what I want to say. If you reach that focus of justice, focus of your own examination of your own work, you don't need any other person to examine your work. If you yourself examine, self-control we can call it. But no, how many people can do it? Means life is different and we don't accept this fact. Therefore, I always stress on quality and coordination. And it's not in our country, it's applicable for every country. But I cannot blame those countries where it works, but where it doesn't work, like my country's leadership in bad quality, my country's leadership in spoiling quality, and that is really major point that we have to see how we can do, how we cannot do. It's really very important to understand. Now there is no current, no light, unfortunately. It has happened and I have to go up and get light on. Only then I can do something. Well, no problem, it's time. If light goes, what can I do? So we have to keep this in mind that working designs a must, manufacturing and construction procedures a must, continuously to do assessment for working considerations for quality goals in all works. And we can say fixed quality in our country, Bharat, India, come what may, no excuse for concessions. Works quality cannot be compromised, and therefore we do not intend to compromise just in name of fragile existing quality system, compliance, formality and excuse. Quality system may fail, but works quality must perform delivered. But it doesn't happen currently in the entire scenario in our Bharat, India. And we say preliminary considerations, where does quality exist? Nowhere I can say. Generally, answer is unsuccessful to find anywhere. Unfortunately, where does quality exist? Unknown conduct it is. And we can say, did you find or can you find for deliberations, red lines to be resolved? Can we bring working environment to quality and coordination requirements? If yes, how to do it? Certain red lines that must be turned green and that must be must. We cannot avoid this. Can we know and apply? Can we know and apply quality standards complied with overseas? Can we know and apply quality standards complied with overseas, for example in GCC countries on buildings and on plant facilities? Can we work on coordination activities to achieve defined or expected quality profile on works? Why we should not revisit quality required specifications and update per word working standards requirements? Why should we not apply coordination requirement? Is it not a most reliable solution? Really, we have certainly worsening state of quality of works, and how to improve such mandated works quality to certain minimum required marks, at least to match with minimum international requirements. Should we not force ourselves to work on coordination in each activity? Worsening state of quality of concrete and how to improve such mandated quality to certain minimum required marks. Concrete component in construction amounts to major percentage of cost, and therefore it becomes incumbent on us to care about quality of each component. It's of course out of common professional understanding why do Why do you have no seriousness in this regard? Worsening state of communication and coordination during working for engineering designs and executions or construction activities. Determined and dedicated role of engineers towards these requirements, or else quality remains a myth. Can we can we do it, or we are inconsistent societies and communities in engineering? Are we engineering force or incapable lot? When shall we awaken ourselves? Shall we transform existing engineering strength into standard quality working force? Who shall decide about all such questions that are being faced? We have to find solution, and it's a fact, because I'm calling them red lines. We have to make them greens, and that's why certain red lines that must be turned green. That must say must. You cannot say no, it should be or it shall be. No, we have to do this. How to do this? That is a big question mark. That's why to find the answer with, and engineers deliberation must. That's also a very important point. And deliberation, that's what my talk is a part of that. Deliberation, we are deliberating on that. And now going to coordination engineering projects, and that's very important point. Coordination engineering projects, public and engineers. And of course, engineers are related. Engineers are responsible for what I'm saying. That's very important, you know. Coordination is that part of life without which we cannot move. Everybody coordinates to itself. My mind coordinates to body, body coordinates to other bodies. We coordinate ourselves, and if we don't coordinate, we find mistakes. We do mistakes, and this coordination I'm talking is engineering coordination, is work coordination, is technical and non-technical coordination both. We have to achieve reliability. We have to achieve reliable quality engineering, or you can say something which satisfies every requirement. Something which satisfies every requirement. Reliable quality engineering works deliveries, for which coordination engineering is a must. A professional engineering note, it is the kind of talk as I said. And missing coordination means missing good engineering. And do you want to miss good engineering? Because engineering can be good as well as bad. Good engineering means construction related engineering, construction or making design engineering, and bad engineering is to think about how to break everything. And that's, I can say, is bad engineering, though not written here, but that is bad engineering, and I should not think of that even. Because if I think of bad engineering, I can say I am against nature, I am against constructive mechanism, I am against myself in that case. I kill myself. Even to kill others means you kill yourself, because you have no right to kill anybody. It's not a spiritual mechanism I'm talking. It's a fact of life that I cannot produce anything, and I have got no right to break that. Even today I cannot, or people cannot produce even a single drop of water, so you have no right to damage water or destroy water or abuse water. You got my point? Just an example I'm giving. Can you produce a 1 centimeter cube of air? You cannot produce. Can you produce a single cubic meter of water? You cannot produce. Can you produce a single cubic centimeter of blood? You cannot produce. Then what can you produce? What can I produce? Nothing. We can only talk, and talking can also be done. We have when we have talking will in our body, talking spirit in our body. Otherwise, we cannot talk even. Take example of eyes. Eyes, everybody has two eyes. Very small size if we compare to body size. Very small size if you compare to size of your face. But these eyes have very powerful, extensive vistas. Your eyes can view stars. Think of that. How far stars are from here? We do not know. And here our eyes can see every physical being, and you cannot measure its power. Think of that. If your eyes are so strong, our minds are so strong, our souls are so strong, then what sort of constructed mechanism we have? It's not I'm talking as medical or for engineering, I'm talking in general. Can you think of your body? How does it work? How can it leave this body? How can you leave this body? Is there given certain mechanism? There's no mechanism. We say, okay, person was leaving, person has gone. We can say only this. And that's what I say. Very important point. We have to be little different in our approach. And that's what I say. I say, यदि समन्वय नहीं तो सबच अभियांत्रिकी नहीं. Here अभियांत्रिकी doesn't mean engineering only. This means life. यदि समन्वय नहीं तो सबच अभियांत्रिकी नहीं. Everybody is to some extent an engineer without education. If we engineer our life in a proper way, and whatever we do in a proper way. Even you cook food, or you clean your floor, or you walk on road, or you do something else. If you do it in a proper way, it's much better than doing it in haphazard way. And communication is important everywhere. We cannot say no. Sanchar avashyak samanvay abhintri hetu. So what I mean to say is coordination engineering, or you can say quality engineering, and based on communication network that is required for purpose of do something. And we have many branches of engineering. It's not one or two, and every branch has its own merits, and it works. My question is, when every people wants to do quality, why does it not happen? Why coordination misses? And when people are very much educated, I think there is always some problem of ego or whatever else. But work does not care if you do proper or don't proper. It will result in a way you do it. Whatever input you do, whatever input you apply in, results will be output. So now point number one is coordination engineering. Is coordination engineering, I say is, let me just blow it up. Yes. It's written, you can see, is coordination engineering a must on every project? That is question. What should be answered? Here project, whatever project, because it's civil engineering, electrical engineering, mechanical engineering, or non-engineering project. I understand. I understand as an individual, as a person, as an engineer, that coordination works everywhere. Is coordination engineering a must on every project? That can be one question. Other can be, project means all performance activities. Project means all performance activities involved from pre-designs to final completion of complete construction. It is long distance travel what I am talking about. Project, which we can define, what is that? Whatever activities are required, performance activities are required, means whatever we have to perform on that project, that involves from pre-designs means before designs, to final completion means when that work is done finally, physically, for purpose of use or for purpose of operation. At that stage I am talking. So we can say project means all performance activities involved from pre-designs to final completion of complete construction. That is one point. Other point is, few difficult questions to be answered by engineering community And what is that? Quality and coordination is a question. Respective involvement in entirety is a question. Can we ignore these domains? Can we? Think yourself. If you ignore, what shall happen? Can we ignore these domains? What do we engineers think about? What do we engineers think over issues as mentioned, and that is quality and coordination and also performance? What do we engineers think over issues as mentioned? How many of us do conduct works per quality and coordination engineering? Coordination, how many of us can do? It's a standard, it's specific, it's a specialty. Coordination is a specialty, or you may even say super specialty. How many of us do conduct works for quality and coordination engineering? Did you ever see somebody can call, I am a coordinator engineer, I am a coordinating engineer, I am a quality engineer? They would always say, I'm a quality assurance engineer. Nobody says that I'm quality engineer. And there's a gap between quality engineer and quality assurance or quality requirement engineer. We'll discuss that later on. Is it not right time to contemplate and deliberate on this subject? What do you say? I say, always time is right. Is it not right time to contemplate and deliberate on this subject? Then we say, can good industrial practice be achieved without moving through quality and coordination domains? That's a big question. Can good industrial practice be achieved without moving through quality and coordination domains? Can engineering design be reliably carried out? Can engineering designs be reliably carried out without involving quality and coordination? This is a question which everybody has to think and answer. Again I say, can engineering designs be reliably carried out without involving quality and coordination? But where are we going to? I have missed, I'm sorry. But where are we going to? Again I repeat these questions for you. You have to think a lot many times. Number one, is coordination engineering a must on every project? Project means all performance activities involved from pre-design to final completion of complete construction. For difficult questions to be answered by engineering community, few difficult questions, quality and coordination, respective involvement in entirety. Can we ignore these domains? What do we engineers think over issues as mentioned? How many of ourselves do conduct work for quality and coordination engineering? Is it not right time? Is it not right time to contemplate and deliberate on this subject? Can good industrial practice be achieved without moving through quality and coordination domain? Can engineering designs be reliably carried out without involving quality and coordination? But where are we going to? And that's what is a communication support for reliable coordination. I'll come back to it later on. Now I move on to concrete file, which is very important one. You continuing this. I was here last time, I left somewhere, and that's what I'm saying about, and that is, it's very important file. We can see, you can say very important file it is. Let me go fast on this. I don't waste time. I think it is page somewhere. If you see, here is we are somewhere on quality. I remember we crossed these flow charts. We were on quality. Yeah, this is construction planning. We have gone through examples. We have taken finishing what are examples of construction planning, and this is determination of concreting methods, determination of construction performance of concrete. No, I think this was not that one. I will say constitution of construction planning, and before that there was design document specifications. We are somewhere here, I think, design of structures. Here is general and approved construction, shall be approved construction. Yeah, I think I did construction plan. Definitions, verifications, inspections, quality control. Yeah, domain engineer, we defined that. Also, we remember we defined it. Construction plan. Okay, we did that one also. Then it was done, and we had to go to construction planning. A construction plan shall be prepared taking into consideration environmental conditions and construction conditions for construction site, giving consideration for construction safety and environment. Okay. Examples of considerations: construction planning, plan for transportation and receiving, haul road plan, compaction plan, finishing plan, joining plan. So this we had done. Determination of concreting method. No, I don't remember. Quality, it was something related to. Yeah, okay. Only metals of proven quality shall be used as concrete metals. Let's read this first of all, what it says, because it's very important. Even if it is revised, no problem. Is revisited, no problem. That's not a point. It says using appropriate materials. It says materials of proven quality shall be used as concrete materials. Using appropriate materials is very important for producing concrete. Using appropriate materials is very important for producing concrete with required performance. A little bit on. Using appropriate materials is very important for producing concrete with required performance. Whether particular materials are suitable for use can be judged from test results or past performance data. In general, materials conforming to Japanese specifications, JSC standards, or the quality standards may be deemed to be materials of proven quality. It's possible, however, to meet performance requirements for concrete even if materials not conforming to quality standards are used. If such materials are used, it must be ascertained in advance that performance requirements for concrete structure can be met. Concrete materials of whatever quality may be used as long as concrete made by using those materials meet performance requirements. In case of poorly field tested materials, however, it is necessary to carefully evaluate respective quality and performance of concrete, including long-term stability of quality and influence on durability of structure made of those materials. Concrete mix design. Concrete mix proportions shall be determined taking into consideration such factors as constraints, related concrete plants, availability of materials, and economy, including transportation cost, so that required performance of concrete can be achieved. Mixed design refers to series of tasks performed to specify materials and mix proportions so that performance requirements for concrete can be met. Usually in mixed design process, materials and respective mix proportions are assumed and trial mixing is carried out. And this cycle is repeated until it is confirmed that concrete mixes made in this way meet all performance requirements. Characteristic values, we define that. Because there are many combinations of materials and their respective proportions that meet performance requirements. What is to be done in mixed design stage is to select appropriate ones from those combinations. Performance attributes required of concrete here include characteristic values for concrete indicated by design and construction performance of concrete, material conditions and mix requirements shown for reference only. Verification of concrete performance. It shall be verified that concrete made with selected materials and mixed proportions meets characteristic value criteria indicated by design. Characteristic, grade of concrete. Grade of concrete is very important that we have to consider when we design, and then what percentages or what by weight mixing, by weight methods means weighing every ingredients we decide that, not by volume. If design indicates reference only values related to construction besides characteristic values, it shall be verified that selected materials and mixed proportions meet reference only values or meet concrete performance requirements on which reference only values are based. Some commentaries here. I think we had gone through this. I remember this equation we discussed with. Again, I read, no issue. Commonly used methods of concrete performance verification as of this writing include experiment-based methods and method of making inference from past performance data. Characteristic values for concrete to be verified include strength number 1, carbonation rate number 2, carbonation rate coefficient you can say, and diffusion coefficient of chloride ions. These are 3 items. First of all, strength, carbonation issue and chloride penetration issue. Then we say freeze thaw resistance, that where ice snowfall exists, and chemical attack resistance, sulfate against chloride attacks like the alkali silica reaction resistance, water permeability coefficient, water penetration, fire resistance and drying shrinkage, strain, etc. So there are so many requirements you can say. You can list this in your mind also. First is strength, very important point, then carbonation and chlorination, or chlorides you can say, freezing and thawing, chemical impacts on concrete, alkali silica and water permeability, fire resistance and drying shrinkage, and many more could be. Values indicated for reference only, such as material conditions and mix requirements, workability, pumpability, setting property. Workability we generally use, so you say slump control we are taking, slump is workability. So his workability, and that leads to pumpability also, and that leads to how to pour it, and of course setting properties after pouring, and after setting properties strength development, it is strength development properties, and we can say specified in construction plan that we have to do, which need such, we have to verify that. And there's a criteria we can say here, it is gamma P, the factor of safety for accuracy. Gamma P is factor of safety for accuracy of AP, and AP is predicted value for a performance attribute of concrete. AP predicted value, while gamma P is safety for accuracy AP, and AK is characteristic value for performance attribute of concrete. So we say equation is gamma P, that is factor of safety for accuracy of AP, gamma P multiplied by ratio of predicted value for performance attribute divided by characteristic value for performance attribute, which should be this product, this is the formula, gamma P into AP over AK should be equal to less than 1, or it can be gamma P AK over AP, reversal of previous ratio, also less than equal to 1. It is the formula for considerations and criteria. We're talking in generality. If even a single characteristic value among specified values is not met, selected materials and mixed proportions are altered and verification is performed again. If rational mixed proportions for concrete cannot be determined by this method, all conditions including structural conditions, reinforcement, material conditions, concrete manufacturing conditions, placement conditions and maintenance conditions shall be reconsidered. That's an important point. So I read it again. If even a single characteristic value among specified values is not met, even a single value is not met, selected materials and mix proportions or ratios are altered and verification is performed again. If rational mix proportions for concrete cannot be determined by this method, In that case, all conditions including, all conditions including structural, reinforcement material, concrete manufacturing, placement and maintenance shall be reconsidered. This is basic. Now, confirmation alteration of construction plan, that's also an important point. It must be confirmed by an appropriate method that concrete construction plan meets requirements for construction work and that performance requirements for structure are met. Whatever change we can say in construction plan should be made so as to minimize its influence. As a general principle, a general rule, changes in construction plan should be limited to concrete mix proportions and construction methods and not to something else. If construction plan differs from reference values indicated at design stage, cracking checks at construction stage shall be made again under conditions reflecting construction plan. Here is some commentary. We can read it again, though I think I have done it before, no problem. The construction plan must meet requirements for construction work, and must be such that concrete structure built in accordance with plan meets performance requirement. Contractor submits a construction plan in writing to owner, and owner checks whether structure shown in design drawings and specifications can really be constructed and approves construction plan. To be more specific, it's necessary to check each task in accordance with items and descriptions to determine whether standard construction methods specified in construction standards of the specification are used, whether plan has an adequate margin of safety against variable factors expected in connection with each task, whether plan incorporates troubleshooting methods, etc. If new technologies or new construction methods are to be used, it is necessary to evaluate respective feasibility and reliability by referring to reliable documents or conducting full-scale trials. If construction plan is to be changed, resultant changes in other conditions should be minimized. A realistic way is to stay within framework of reconsidering construction plan instead of reverting to design of concrete structure. Usually, making changes in concrete mix proportions or construction methods is specified in construction plan suffices. At design stage, concrete and its placement methods are assumed. Checks are made on initial cracking and characteristic values for concrete are determined. If these conditions in construction plan differ from conditions assumed at design stage, verification on cracking shall be made again on an as required basis at construction stage. Construction now we talk of. Construction of concrete structure shall be carried out in accordance with construction plan because we have planned it. So that's one part. We have planned it and it shall be done accordingly. Construction of a concrete structure shall be carried out under supervision of a domain engineer with sufficient knowledge and experience in construction of concrete structures stationed at construction site. If construction plan cannot be followed at construction stage, appropriate measures shall be taken so that performance requirements determined at design stage can be met. Basic rule for construction is to carry out construction work economically and efficiently by using an appropriate construction method on condition that construction safety is maintained. Because concreting work involves a variety of tasks such as tasks related to form work, reinforcing steel, placing of concrete. It is desirable that concreting work be thoroughly coordinated with other types of works so that construction work can be carried out efficiently. And here what we talk is coordination, technical and engineering coordination. To construct a concrete structure, constructor or contractor prepares a construction plan details details necessary construction processes based on design drawings and specifications. Construction of concrete structure therefore must be carried out in accordance with construction plan, which is based on communication and coordination. In general, quality of construction is heavily dependent on human factors such as experience and quality of constructors. Very important therefore is to station domain engineers with sufficient knowledge and experience in field of construction of concrete structures at construction site so that construction work carried out under direction of these domain engineers. In a construction project, incidents not expected at planning stage may occur at construction stage. In construction project, incidents not expected at planning stage may occur at construction stage. It's not always possible, therefore, to carry out construction in accordance with construction plan. If it's difficult to follow construction plan in a real construction project, appropriate measures must be taken following domain engineers' instructions so that required performance can be achieved. Quality control. Now we come to real talk. Till now it was revision or refresher. Contractor shall perform control. Contractor shall perform control, or that's quality control at each stage of construction in order to create a concrete structure that meets performance requirements. Quality control shall be performed as a voluntary activity of contractor, though it is legal. Contractor says quality control shall be performed as a voluntary activity of contractor by using a method that can be expected to be effective. If quality control has revealed a possible quality problem, appropriate measures shall be taken in accordance with domain engineer's instruction so that performance requirements specified at design stage can be met. Now some comments say, in order to create a concrete structure that meets performance requirements, contractor must carry out construction in accordance with construction plan and perform quality control by appropriate methods. For appropriate items such as concrete materials, reinforcing materials, equipment and construction methods to ensure that required quality is achieved at each stage of construction. It is advisable, however, to perform quality control only for necessary items as often as necessary. Instead of conducting many types of tests and collecting a large amount of data, one way to check on quality on basis of test results, besides actually conducting tests, is to examine manufacturers' test reports, as in case of GIS conforming products. Alright. Usually wide variations in quality of concrete placed to build a structure not only increases possibility of occurrence of problems, usually wide variations in quality of concrete placed to build in a structure not only increases possibility of occurrence of problems at construction stage, it also necessitates use of a large factor of safety at mixed design stage so as to achieve required strength. That makes construction process uneconomical and in many cases causes decreases in durability. Causes decrease in durability. Cracking resistance and appearance. Always producing concrete of stable quality, therefore, is essential, and it is important to control quality of materials and concrete manufacturing process carefully. Contractor must prepare a reliable, efficient and economical Contractor must prepare a reliable, efficient and economical quality control plan in accordance with construction plan and carry out construction work in accordance with quality control plan. Quality control results may be used as substitutes for results of inspection conducted by owner at each stage of construction. It's desirable, therefore, that quality control be performed wherever possible by a technically or otherwise proven method. If quality control has revealed a sign of considerable variation in quality, it is necessary to conduct an investigation to identify cause of such variation and take corrective measures so that variations can be kept within predetermined range. In event of abnormality or a possible quality problem, appropriate measures must be taken in a timely manner in accordance with a domain engineer's instruction. Inspection. Owner shall conduct inspection at each stage of construction and upon completion of structure on owner's own responsibility. Actually it should be engineer, no problem. Let us see what the Japanese specimen says. Owner of a structure shall draw up an inspection plan in accordance with design drawings and specifications, taking into consideration degree of importance, intended use and purpose of structure. Owner of a structure shall draw up an inspection plan in accordance with design drawings and specifications, taking into consideration a degree of importance, intended use and purpose of structure. Inspection shall be conducted in accordance with inspection plan by a method of proven reliability. Inspection shall be conducted in accordance with inspection plan by a method of proven reliability. If inspection is failed, corrective measures to be taken shall be considered. If corrective measures cannot be taken, stage of construction that failed to pass inspection shall be redone. Inspection plan and inspection results shall be maintained during service period of structure. What comments we have? In order to construct concrete structures as indicated in design drawings and specifications, inspection is conducted. Down all video and audio, and we have to be very careful about this, why it is down. So no problem. It's back again. In order to construct a concrete structure as indicated, in design drawings and specifications, inspection is conducted at each stage of construction to check whether construction work being carried out is adequate or it is not adequate. Required performance of concrete structure can be ensured by checking on performance requirements such as safety at design stage and conducting inspection at construction stage. Inspection therefore must be conducted on responsibility of owner of structure. Performance of a newly completed concrete structure should ideally be inspected directly. Items related to concrete structure that can be inspected, however, are limited to only a fraction, namely concrete surface, condition, locations, shapes, dimensions, etc. of structural members of all inspection items. A realistic approach, therefore, is to conduct necessary inspection at each stage of construction to make sure through a series of inspections that concrete structures constructed being constructed as indicated in design drawings and specification. Owner of structure requires to drop a reliable, efficient and economical inspection plan with reference to design drawings and specifications. In view of degree of importance, intended use and purpose of structure, in general, inspection is planned taking into consideration such factors as type and scale of construction work, staffing, timing of construction period, reliability of materials and construction methods used, skill level of construction workers, degree of influence of work schedules at subsequent stages, and efficiency. Inspection plan must describe thing to be done, inspection criteria, etc. It's not practical that owner inspects all items because inspection items are diverse at each construction stages. In this way, contractor inspects quality inspection items for materials except for inspection related to construction works and structure on their own responsibility, and owner ensures inspection results. What says it's not practical that owner inspects all items because inspection items are diverse at each construction stages. Contractor inspects quality inspection items for materials except for inspections related to construction works and structure on their own responsibility. Owner ensures inspection results. To make this practice work, owner should discuss inspection methods with contractor before actual construction begins. Results of discussion should be recorded with written documents where owner records on an inspection planning document while contractor records on a construction planning document. Now here owner is referred to, actually it is owner's representative who can be an engineer. So just yes, owner, of course the engineer works on behalf of owner and contractor also works on behalf of owner, because owner of structure has to judge acceptability of concrete structure through inspection. Reliability of inspection methods required to be ensured by supportive the technical information or evidence. Acceptability criteria are one of important items agreed upon in contract. So it must be objective. Common practice is to use methods specified in Japanese industrial standards or IJSCE standards. Construction inspection standards of the specifications indicates standard inspection methods and criteria for evaluating acceptability of inspection results based on respective standards and specifications. Owner specifies in advance inspection related requirements such as inspection items, inspection methods, and acceptability criteria in contract documents. Signals are gone, what to do? Alright, my God, I'm dependent on signals, so what to do? Well, again I say, owner specifies or engineer specifies an advance inspection related requirements such as inspection items, inspection methods, and acceptability criteria in contract documents, which we have been discussing. And as a general rule, specifies all requirements in contract documents. However, inspection that need be conducted at different stages of construction involves involving a wide range of inspection results and inspection items. It's desirable that studies be conducted in advance on such details as inspection items, inspection methods, timing, frequency, staffing, cost, and required time, and agreement we reach with contractor concerning particularly detailed matters so that inspections can be conducted in a reliable, efficient, and economical ways. If newly deployed construction method or material is used, conventional, you can say, conventional inspection methods may not be adequate. If a newly developed construction methods or material is used, conventional inspection methods may not be adequate. It is therefore important for owner to draw up an inspection in consultation with contractor. If inspection has been failed at stage of construction, it is necessary either to redo stage of construction or take corrective measures. In this case, it must be confirmed that required performance of concrete structure can be achieved by taking corrective measures. Contractor therefore requires carefully determine construction procedures and details in advance in connection with construction tasks that are difficult to redo. If an inspection has been failed or inspection has failed, and neither taking corrective measures nor redoing construction is possible, it is necessary to evaluate influence of problem on required performance of concrete structure and take appropriate measures such as demolishing and reconstructing structure or altering maintenance plan and using existing structure. Inspection records are documents that certify that concrete structure has been constructed in accordance with construction plan and as indicated in design drawings and specifications. Inspection records therefore must be maintained during service period of concrete structure. If an inspection is failed at one or more stages of construction, it is important to record in details facts including corrective measures taken. Inspection plan. Inspection plan specifies inspection item, inspection methods and requirements such as acceptable criteria, timing and frequency of inspection and staffing. Requirements needed ascertain that structure concerned is being constructed as indicated in design drawings and specifications. In event of change in design drawings or specifications, inspection plan shall be reviewed. Inspection items, inspection methods and requirements such as acceptance criteria, timing and frequency of inspection and staffing requirements need ascertain that structure concerned is being constructed as indicated in design drawings and specifications must be determined and specified in inspection plan. It is fully charged. Let me just put down battery so that it is not overcharged. Okay, let's move further and see how can it work better in this way. So we move forward. Inspection items, again I read inspection items, inspection methods and requirements such as acceptance criteria, timings and frequency of inspection, and staffing requirements needed to ascertain that structure concerned is being constructed as indicated in design drawings, and specifications must be determined and specified in inspection plan. Standard inspections usually consist of following, and that is inspection of quality of concrete materials, inspection of performance of concrete plant inspection of performance of concrete plant, that is batching plant or mixer, inspection of quality of concrete, inspection of quality of reinforcing materials, inspection of construction, inspection of structure. So concrete materials, concrete plant, concrete quality, reinforcing material quality, construction inspection and structures. These are main. A series of inspections conducted in connection with construction of a concrete structure includes inspection of materials, that is concrete and reinforcing bars, conducted to ensure that materials used are appropriate. Inspection of construction conducted mainly to ensure that structures and its members meet dimensional requirements. Specified reinforcing bars have been placed at specified locations. Concrete has been uniformly placed and compacted, and curing has been carried out as required. Inspection of concrete structure. All this point I repeat, this is very important. So it is that a series of inspections conducted in connection with construction of a concrete structure includes inspection of materials, and that is concrete and reinforcing bars, conducted to ensure that materials used are appropriate. Inspection of construction conducted mainly to ensure that structure and its members meet dimensional requirements. Specified reinforcing bars have been placed at specified locations. Concrete has been uniformly placed and compacted, and curing has been carried out as required. Inspection of concrete structure. After these inspections are passed, it may be judged that concrete structure has been constructed as indicated in design drawings and specifications. It's desirable that inspection be conducted only for essential items in view of construction efficiency and economy. Inspections that are deemed necessary in order to check whether concrete structure indicated in drawings and specifications can be constructed must be conducted after reliability is ascertained. Example is, if it's thought likely that adequacy of construction when newly developed materials or construction methods are used cannot be judged by means of inspections. In that case, through listed above inspection methods suitably for such materials or construction methods must be adopted. In such cases, it is very important to confirm inspection details through in-depth discussion between owner and contractor, because inspection plan is drawn up on basis of design drawings and specifications. If inspection plan has been changed, it must of course be reviewed. Conduct of inspection. Inspection shall be conducted in accordance with inspection plan. Person responsible for inspection shall judge acceptability of inspection results in accordance to predetermined evaluation criteria. Comments being basically inception basically you can say inspection of structure must be conducted by owner or representative engineer of structure on responsibility of owner in accordance with inspection plan. Inspection tasks need be performed under direction of a person who has experience in working in construction work concerned or who has technical experience. If inspection at a stage of construction has failed, either construction work concerned is redone or corrective measures are taken after discussion between owner and contractor. Inspection methods used after corrective measures are taken must also be technically proven, reliable methods. Person responsible for inspection must be owner or owner's agent and need be a senior professional engineer certified by Japan Society of Civil Engineers, consulting engineer, concrete specialist, chief concrete engineer or an equally competent person. Maintenance of inspection records. Maintenance of inspection records. Inspection records shall be maintained during service period of concrete structure. Inspection records covering necessary items shall be maintained in an appropriate format with reference to maintenance guidelines. Here comments, inspection records are important records or documents confirming required performance of concrete structure, like design drawings and specifications and inspection plan. Therefore, inspection records must be maintained. If an inspection has been failed and corrective measures been taken, records regarding their details must also be maintained. Because inspection records are important as initial values for maintenance of a newly completed concrete structure, this must be maintained as source of reference information so that safety, serviceability, etc. of concrete structures can be ascertained. Construction records. General, owner of a concrete structure shall maintain construction records during service period of concrete structure. Term construction records here refers to design drawings and specifications including changes. Construction plan including changes. Inspection plan including changes and inspection records. It is also good practice to maintain records concerning construction management depending on degree of importance and necessity. These documents contain all information concerning newly constructed concrete structure that can be used as basic data for ensuring required performance of structure during its service period. It is desirable that these documents indicate affiliations, names, etc. of persons who performed relevant tasks. It is desirable, means not necessary. Construction standards. General construction standards. Purpose of this specification, materials and construction. Construction standards of standard specifications for concrete structures to make it possible in concreting work for new construction of an ordinary civil engineering structure to construct a concrete structure of a certain level of quality by carrying out items indicated herein without pain is taking attention. Repeat. Purpose of this specification, materials and construction, that is construction standards of standard specification for concrete structure, is to make it possible to in concrete work for new construction of an ordinary civil engineering structure. To construct a concrete structure of certain level of quality by carrying out items indicated herein without paying painstaking attention. Prior to commencement of concrete work, it is necessary to fully understand contents of design drawings and specifications and prepare an appropriate construction plan. If details such as materials used, construction conditions, construction environment or construction methods deviate from conditions indicated in construction or construction standards of this specification, a construction plan consists with construction general requirements of this specification shall be prepared and construction shall be carried out accordingly for items indicated in construction. Special concretes of this specification should be referred to. Commentary. Concrete work varies very widely because of diverse elements and conditions, such as type of structure, materials used, construction conditions, construction environment and equipment used for construction. It's also true, however, that most concrete construction projects involve very few special items. Numerous concrete construction projects of this type have already been successfully carried out in many cases. Therefore, it's rational to adopt a construction plan that can be drawn up by making minor modifications to an ordinary construction plan to suit site specific conditions. Construction standards of this specification is intended for application to such ordinary concreting work as a standard guideline. Construction general requirements. Construction standards and construction special concretes of this specification should be used as follows. That is construction special concrete. Here construction standards, this is construction standard, that's this document indicates typical items to be carried out in connection with type of structure, materials used, construction equipment and construction conditions within range applicable to a typical civil engineering construction project. 2002 edition of construction section of this specification had an independent chapter on inspection. Other chapters dealt with items to be carried out by contractor, while chapter on inspection deals extensively with items to be carried out by owner of structure. Construction sections of current specification therefore has separate volumes, construction standards and construction inspection standards for construction and inspection to clarify responsibilities of each party and make this specification easier to use. Inspection related items to be carried out by contractors, such as items related to receiving materials, are described in construction. Construction standards, construction standards and construction inspection standards are designed for use as a kind of standard specifications for many construction projects. Typical construction work to which construction or construction standards of this specification is related or applicable involves, for example, specified strength of concrete of up to about 60 Newton per meter square, minimum slump at time of placement of 16 centimeter or less, cubic meter, minimum slump at time of replacement of 16 cubic meter or less, use of agitator trucks, for off-site transportation, use of pumps for on-site transportation over equivalent horizontal pumping distance of 150 meters or less, and use of internal vibrators for compaction. Among items related to materials, construction conditions, construction environment beyond these ranges, those that have been field tested to a certain extent are described in construction special concretes of this specification. It's assumed that in case where items related to material, construction conditions and construction environment beyond these ranges are involved in cases where special attention is required, or in cases where special expertise is to be used effectively. A construction plan is drawn up on a case-by-case basis in accordance with construction general requirements of this specification. Verification is made and then construction is carried out. In all civil engineering construction projects, it is important to draw up an appropriate construction plan according to site specific conditions prior to commencement of construction. In concreting work, it is necessary to fully understand content of design, drawings and specifications and draw up an appropriate construction plan for prior to commencement of construction, taking into consideration such factors as functionality, strength and durability. Functionality, strength and durability required of structures, and important things to keep in mind in carrying out construction work. As mentioned in explanation about commentary, however, concreting work in most cases consisting of combination of more or less standard tasks that include very few special items. Furthermore, in cases where concrete structure to be constructed has been carefully designed so as to avoid spatial construction conditions such as excessively dense reinforced pattern, a sufficient level of quality can usually be achieved by performing standard construction management. In such cases, a rational approach is to use items indicated in construction standards of this specification by making minor changes to those items. The following procedures described herein is not easy. It's not easy to at many construction sites to draw up a special construction plan. Many troubles encountered in construction of concrete. Many troubles encountered in connection with construction of concrete structures result from inadequate attention paid to construction at design stage. Designer and constructor therefore need no assumptions made by other party within their respective scopes of work. In case of construction of an ordinary concrete structure, design and constructions are usually performed separately. Design and constructions are usually performed separately and information is seldom exchanged directly between designer and constructor. In an ordinary project, therefore, designer requires to perform design tasks with a full understanding of scope of construction standards of this specification. If design tasks are to be performed on basis of assumptions that deviate from scope, it is necessary to clearly indicate it in design drawings and specifications in order to prevent formation of problems at construction stage. When using special materials production or construction method that are not covered in construction special concretes of this specification. Separate specification in which provisions of this specification are appropriately reflected shall be prepared for reference. Following list provides guidelines and manuals dealing with special materials and construction methods, published by JSCE. Recommended practice for concrete made by continuous mixer, 1986, Japanese. Recommendations for design and construction of reinforced concrete structures using D57 and D64 large diameter threaded requirement bars, 1992. Recommended practice for concrete containing air entering and high range water reducing agents. Recommendations for construction of high fluidity concrete. Guideline for construction using blast furnace slag aggregate, 1993. Recommendations for design and construction of concrete structures using silica fumes in concrete, and recommendation of construction of concrete using ferro-nickel slag fine aggregate. Recommendation for construction of concrete using copper slag fine aggregate. Recommendation for construction of concrete containing fly ash, and recommendation for concrete pumping, 2000 in Japanese. Okay. Recommendations for designs and construction of concrete. Recommendations for design and construction of concrete structures using electric arc furnace, oxidizing slag aggregate. Recommendations for design of reinforcement concrete structures using epoxy coated reinforcing steel bars. Recommendations for mixed design and construction of concrete based on placeability. Recommendations for design, fabrication and evaluation of anchorages and joints in reinforcing bars. Recommendations for concrete repair and surface protection of concrete structures. Definitions. How many percent batteries now? 79. Terms used in standard specifications for concrete structures. Terms used in standard specifications for concrete structures. Construction standards are defined as follows: is concrete, mortar, cement paste, and plain concrete, reinforced concrete, prestressed concrete. Let's say concrete. Concrete is a composite material or its hardened form. Its hardened form consisting of materials such as cement, water, fine aggregate, and admixtures added if necessary to be blended together by mixing or other methods. Mortar, a composite material, or its hardened form consists of materials such as cement, water, fine aggregate, and admixtures added if necessary to be blended together by mixing or other methods. Cement paste, composite material or its hardened form consisting of materials such as cement, water, and admixtures added if necessary to be blended together by mixing or other method. That is, cement paste, a composite material or its hardened form consisting of materials such as cement, water, and admixtures added if necessary to be blended together by mixing or other methods. Plain concrete, concrete without reinforcing steel materials, including concrete containing only secondary reinforcement as a precaution against cracking due to shrinkage or other reasons. Reinforced concrete is strengthened. Concrete is strengthened by reinforcing bars. Concrete is strengthened by reinforcing bars designed on assumption that two materials act together in resisting external forces. Prestressed concrete. Prestressed concrete, a type of reinforced concrete. A type of reinforced concrete prestressed by means of prestressing, steel, etc. Aggregate, sand, gravel, sea sand, gravel, sea sand, crushed sand, crushed stone, blast furnace slag, fine aggregate, blast furnace slag, coarse aggregate, and other similar materials which are mixed with cement and water to produce mortar or concrete. Sieve, a wire sieve specified in GIS Z88001 used for tests of concrete and concrete materials. Fine aggregate, aggregate entirely passing 10 mm sieve with more than 85% of its weight. Coarse aggregate, aggregate with more than 85% of its weight retained on 5 mm sieve. Sand, fine aggregate formed from rocks through natural processes. Gravel, coarse aggregate formed from rocks through natural processes. Recycled aggregate, aggregate for use as concrete material manufactured by performing crushing and other processing of concrete fragments recovered from demolished structure. Grade, grading of aggregate, size, distribution of aggregate particles. Fineness modulus of aggregate Fm, a factor obtained by adding total percentages, by weight of an aggregate sampled retained on each of a specified set of sieves, namely 80, 40, 20, 10, 5, 2.5, 1.2, 0.6, 0.3 and 0.15 mm, and dividing sum by 100. So what is that? Adding total percentages by weight of an aggregate sample retained on each of specified sets of sieve and dividing by sum by 100. Solid volume percentage of bulk aggregate, ratio of solid volume of aggregate filled in container to volume of that container expressed as percentage. Maximum size of coarse aggregate, specified by nominal size of smallest of all sieves through which at least 90% aggregate by weight passes. That is what? Maximum size of coarse aggregate, specified by nominal size of smallest of all sieves. Size of coarse aggregate specified by nominal size of smallest of all sieves through which at least 90% aggregate by weight passes. Surface moisture of aggregate. Surface moisture of aggregate. Free water retained on surface of aggregate material, aggregate particles. Free water retained on surface of aggregate particles. It is accounted for as a portion of mixing water and obtained by subtracting amount of water absorbed inside aggregate particles from total amount of water retained by aggregate. Such surface dry state of aggregate, let me again say surface moisture of aggregate, free water retained on surfaces of aggregate particles. It is accounted for as portion of mixing water and obtained by subtracting amount of water absorbed inside aggregate particles from total amount of water retained by aggregate. Surface dry state of aggregate. State of aggregate particles in which there is no water on exposed surfaces. State of aggregate particles in which there exists no water on exposed surfaces and permeable voids inside are filled with water. Saturated surface dry state for ordinary aggregate. That is, surface dry state of aggregate particles in which there is no water on exposed surfaces and permeable voids inside are filled with water. Permeable voids inside are filled with water. It's called saturated surface dry state for ordinary aggregate. Oven dry state of aggregate. State of aggregate particles in which all water contained in permeable voids is removed by drying at temperature between 100 and 110 degrees Celsius until their mass become consistent. Density of surface dry aggregate. Density of surface dry aggregate. Density obtained by dividing weight of aggregate in saturated surface minus dry state into its absolute volume. Density of oven dry state aggregate. Density obtained by dividing weight of aggregate in oven dry state into its absolute volume. Total moisture content of aggregate. Percentage of total weight of water inside and on surfaces of aggregate to weight of aggregate in oven dry state. Absorption capacity of aggregate. Absorption capacity of aggregate. Better if you give me some time, I'll be back for 5 minutes only. I'll be back because it is important to go for 5 minutes. Let me be 68%. I'll be back by that time. Just 5 minutes, please. Okay. Invite colleagues for your answer, please. So we are here with this. We are here with, that is what we can say here is that is absorption capacity of aggregate, percentage of total weight of water, percentage of total weight of water in surface dry condition, in surface dry state of aggregate, to weight of aggregate in oven dry state, that is absorption capacity, percentage of total weight of water in surface dry state of aggregate to weight of aggregate in oven dry state. Effective absorption of concrete, this was absorption capacity of aggregate, and effective absorption is a percentage of weight of water that aggregate absorbs to reach saturated surface dry state, to weight of aggregate in oven dry state. Surface moisture content of aggregate, percentage of surface moisture of aggregate to weight of aggregate in saturated surface dry state. Powdery material, a collective term for cement and other solid materials used as concrete material that is as fine as or finer than cement. That's powdery material. A collective term of cement or other solid material used as concrete material that is as fine as or finer than cement, that is powdery material. Binder, generic name for materials which react with water or and participate in strength development of concrete, such as cement, granulated, blast furnace slag, fine powder, fly ash, etc. Admixture, materials other than cement, water and aggregate added to concrete before placing to impart special properties. Mineral admixture, kinds of admixture. Admixture, you say, mixture other than cement, water and aggregate added to concrete before placing to impart special properties. Mineral admixture, kind of admixture which was used in comparatively larger quantities and volumes of which are taken into account in calculating mixed proportion of concrete. Mineral admixture is admixture which are used in comparatively larger quantities and volumes of which are taken into account in calculating mixed proportion of concrete. Chemical admixture, kinds of admixture which are used in small quantities and volumes of which are neglected in calculating mixed proportion of concrete. Entrained air, tiny isolated air bubbles introduced in concrete by using air entraining agents or chemical admixtures. Entrained air it is, and entrapped air. Air bubbles formed in concrete naturally without use of chemical admixtures. Air entrained concrete. Concrete that contains entrained air. So there are, one is entrained air, other is entrapped air, and one is air entrained concrete. Entrained air, tiny isolated air bubbles introduced in concrete by using air entraining agents or chemical admixtures, and entrapped air bubbles formed in concrete naturally without use of chemical admixture. And air entrained concrete is concrete that contains air, entrained air. Steel, a general term for structural carbon steel consisting of iron as its principal ingredients. Is carbon steel consisting of iron as its principal ingredients. This includes steel bars for reinforced concrete, pre-stressing tendon, and hot rolled section steel plates. Reinforcing bars, steel bars embedded in concrete for reinforcing purpose. Plain bars, circular steel bars with uniform round cross section. Deformed reinforcing bars, deformed rebars, steel bars that have surface projections such as ribs to improve bond with concrete. Stress introduced in concrete before application of service loads to reduce tensile stresses induced in concrete by loads. Pre-stressing steel, high strength steel used for pre-stress concrete. Spacer devices used to provide a given cover to reinforcing bars, tendons or sheaths, etc., and maintain correct space between them. Creep, time dependent phenomenon in which deformation except elastic strain and trank shrinkage strain, in which deformation increases under constant sustained load. Creep. Deformation increases, time dependent phenomenon in which deformation increases under constant sustained load. Clearance, clear distance between adjacent reinforcing bars. Cover, concrete thickness expressed by least distance between outer surface of concrete and surface of steel or sheets. Mixed proportion, proportion or quantity of constituent materials. Proportion or quantity of constituent materials to produce a desired quantity of concrete or mortar. Trial mixing carried out to determine whether a specified concrete can be obtained from a designed mix. Characteristic compressive strength of concrete, strength on which structural design is based. Generally, it is compressive strength at 28 days notation F-CK. Mixed proportioning strength, target strength. Compressive strength used to select mixed proportion of concrete. Generally, it's a compressive strength at 28 days notation F-CR. Allowance factor, a factor of safety factor by which specified average strength is multiplied. Specified average strength is multiplied to take into account variation of material quality in determining target strength. Allowance factor is factor by which specified average strength is multiplied to take into account variations of material quality in determining target strength. Water cement ratio, ratio by weight of water to cement in cement paste in fresh concrete or fresh mortar is generally expressed in percentage. Unit content, quantity of material used for producing 1 cubic meter of concrete or mortar that is unit cement content, unit water content, unit weight of coarse aggregate, unit weight of fine aggregate, unit weight of admixture mineral, and unit weight of admixture. Powdery material content, a total quantity of powdery material used to make 1 cubic meter of concrete or mortar. Cementitious material content, quantity of cementitious material used to make 1 cubic meter of concrete or mortar. Sand aggregate in ratio, ratio of absolute volume of fine aggregate to that of total aggregate. Sand aggregate ratio of absolute volume of fine aggregate to that of total aggregate, expressed in percentage notation, that is SA, sand aggregate ratio. Unit volume of dry rotted coarse aggregate, bulk volume of coarse aggregate to produce 1 cubic meter of concrete. It's obtained by dividing unit weight of coarse aggregate into its weight per unit bulk volume. Fresh concrete, fresh mortar, fresh paste, concrete mortar or paste which has not hardened yet, respectively. Slump, an indicator of degree of softness of fresh concrete, measured as distance by which concrete surface falls after slump cone is lifted. An indicator of a degree of softness of fresh concrete, measured as distance by which concrete surface falls after slump cone is lifted. Bleeding, phenomenon in which a portion of mixed water emerges from fresh concrete, mortar or paste due to sedimentation or segregation of solid materials. Latence, a relatively weak layer formed on surface of concrete, mortar or cement paste by tiny particles brought to surface during bleeding. Consistency, property of fresh concrete, fresh mortar or fresh paste which is mainly dependent of water content, shown by degree of resistance to its movement or deformation. Consistency, property of fresh concrete, fresh mortar, fresh paste which is mainly dependent of water content, shown by degree of resistance to its movement or deformation. Workability property, so consistency is always used, you can say fresh concrete or whatever is mainly dependent on water content, shown by degree of resistance to its movement or deformation. Workability property indicating level of or a fresh concrete to be easily transported, cast, compacted and finished without occurrence of material segregation. Filling ability, among workability attributes, ability of concrete to densely fill cover region and corners of concrete forms, fill cover regions and corners of concrete forms without undergoing segregation. Pumpability, degree of ease with which fresh concrete or fresh mortar can be transported by a concrete pump. Placing height of concrete placed in one lift. Free fall height from which concrete falls in an exposed condition from a chute or pipe and when concrete is placed. Compaction height, maximum height from bottom of concrete form or surface of previously placed concrete to surface on which construction workers stand with performing compaction of concrete. Compaction height. Maximum height from bottom of concrete from or surface of previously placed concrete to surface on which construction workers stand while performing compaction of concrete. Durability, resistance to degradation with time, in performance of concrete structure. Alkali aggregate reaction, phenomenon in which alkali reactive aggregates Alkali reactive aggregates react with cement or other alkali components. Alkali reactive aggregates react with cement or other alkali components in concrete over a long time, causing expansion, cracks, or pop-up. Froth thaw resistance. Resistance against a repeated freezing and thawing action. Frost damage of concrete due to freezing action in initial period of setting and hardening. Chemical attacks. Dissolution or deterioration due to generation of expensive compounds of concrete caused by erosive substances such as acids and sulfates. Chemical attack may cause a loss of concrete cross section or volumetric expansion and may even cause cracking. Spalling of concrete cover and steel corrosion. Water tightness, property of having low water and moisture permeation. Property having low water and moisture permeation. Autogenous shrinkage, phenomenon in which concrete, mortar and cement paste shrink due to reduction in volume during cement hydration. Autogenous shrinkage. Crack resistance, resistance of concrete to crack initiation. Placement interval, time from completion of placement of concrete in underlying layers to initiation of placement of concrete in overlying layers. Cold joint, a discontinuity between a previously placed layer of concrete and next layer of concrete. Batch mixer, a type of mixer in which materials for concrete, mortar or paste are mixed for each batch. Continuous mixture, mixing equipment which contains a set of devices for batching, supplying and mixing materials for concrete and therefore can produce fresh concrete continuously. Ready-mix concrete, fresh concrete that can be purchased at whatever time from plants which possesses facilities for manufacturing concrete with desired properties. Sheathing, wooden, metal or plastic panel type for work directly adjacent to concrete. Wooden, metal or plastic panel type for work directly adjacent to concrete. And sheeting. Equivalent horizontal conveying distance. Total distance of horizontal concrete pipes and equivalent horizontal distance converted from length of vertical pipe. Taper pipe, flexible hose. Quality control, effective and systematic technical activities for ensuring quality of concrete in each stage of construction so that functional requirements of concrete structures are satisfied. Inspection, work of judging whether quality of concrete meets required criteria or it does not. Control charts, charts can be charts used to determine whether construction is proceeding per schedule or to maintain a steady construction process. Mass concrete member or structure whose size is relatively large. Concrete member or structure whose size is relatively large and consideration of or temperature rise due to heat or radiation is of great concern during design and construction. Plasticized concrete. An already mixed concrete is called plasticized concrete if superplasticizer is added into it and a thorough mixing is carried out afterwards to increase flow ability. Standard curing, a method to cure in water or in moist condition under nearly 100% of humidity while temperature is kept 20 plus minus 3 degrees Celsius. Standard curing. A method of curing in water or moist condition, 100% of humidity while temperature is capped at 20 plus minus 3 degrees Celsius. That's a standard curing. Moist curing, a method of curing where concrete is capped in a moist condition for a certain period of time after placing. Temperature control curing, a method of curing where temperature of concrete is controlled for a certain period of time after placing. Insulated curing, a method of curing where necessary temperature is maintained by utilizing heat of hydration of concrete, of cement and preventing escape of heat to utmost by covering surface of concrete with highly insulating materials. That is insulated curing. Method of curing where necessary temperature is maintained by utilizing heat of hydration of cement and preventing escape of heat to utmost by covering surface of concrete with highly insulating materials. Heat curing, a curing method in which concrete is heated by any source of heat during a period of curing. Accelerated curing, a curing method used to accelerate surf hardening process and strength development of concrete. Centrifugal compaction of concrete by centrifugal force using a formwork revolving at an extremely high speed. Casting, production of factory products by placing concrete into a form and applying compaction to placed concrete. Instant demolding, removal of part or all of formworks for concrete and with an extremely stiff consistency immediately after placing compaction using strong vibrations of pressure. In these comments we have here reinforced concrete. Reinforced concrete in the wide sense also includes pre-stressed concrete, steel framed reinforced concrete in which hard rolled sections, steel and shaped steel are used as reinforcing material. However, in this specification, terms refers to concrete containing reinforcing steel bars. Sieves, standard sieves for concrete of JSC C501 is a series of net-like services. Net-like sieves for sieve analysis of aggregates chosen from such sieves specified in the GIS. Standard sieve in JSC standards, only nominal sizes are given for convenience, although actual mesh sizes, diameters of wires, openings and so forth are same as those specified in JSC. Fine aggregate and coarse aggregate. Distance between fine aggregate and coarse aggregate is quite freely decided and has no theoretical grounds. The definitions were made considering customary practice as aggregate prepared on construction sites not screened thoroughly. Aggregate particles passing 5 mm sieve are frequently included in coarse aggregate and particles retained on 5 mm sieve in fine aggregate. Therefore, a 15% allowance in each case has been given. We'll read this, it's a long one, we'll read this later on. So let's go back to something else now and we will see how this works. I also just a little background of myself today, a little background that is just for your information, not just means. I'll give it again also. Start my little small carrier, that is you can say I indicate where I started with, and here is, you can see, my first assignment was Delhi Railway Authority, 1975-1981, 6 years, junior engineer. Then it was second appointment in Ansals Properties India Limited, 1981, where I worked for 0.5 years as junior project engineer in Baghdad. Eurorec Associates, and next one, UK in 1982. I worked for 1 year or more and project engineer site manager, Baghdad. Site India Limited, 9 to 5 years, senior site engineer, Baghdad. Electrical Construction Company, ECO, Government of India and Government Libya, SPLA joint venture, 1983-1984. Project engineer, site manager, Benghazi, Libya, Benghazi, Tripoli and Sirte. Alatia Contracting and Trading Company, Alkit in Doha, Qatar, 1985-1989. 4 years, site agent, contractors agent, project engineer, Qatar. Sky Associates, Delhi, India, 1989-1995. Own practice, 5 years, consultant, planner, designer. Midmac, 1995-96. Project office engineer, Qatar, Ras Lafan, LNG, for LNG tanks and villa. Then Khalsa Contracting and Trading Company. This is 1996-98. 1.5 years, chief engineer, UAE, Abu Dhabi. Then Al Jaber Energy Services, 3.5 years, the UAE's project office, and this is 1992, 2003. Housing, Al Huda Contracting Engineering Works, 2003-2004, 1 year, project manager, Qatar, Doha, Mesaid. Al Jaber Energy Services, UAE, 2004-2008, 4 years, senior project engineer, tendering, estimation contracts, UAE, Abu Dhabi. Housing designs, construction of house in 2008-2010, 1.5 years, India, Bharat, Hyderabad. Pat Engineering, 2010, 0.5 years, half year, project manager, Qatar, Doha. Alawi Tunsi Contracting Establishment, 2011, 2010, I think, I'm saying 2010, 0.5 years, project manager, yes, Jeddah and Pat Engineering. 2010, 0.5 years, project manager, Qatar. Engineering arbitration consultancy, 2012-2016, 5 years, independent, India. And independence practice, current knowledge dissemination online. Just a brief, then after that, doing some, says comprehensive experience is 37 years total, including about 20 years in international contracting. This experience is only for companies. Others are not taken into this, like what happened on internet. Taking information, but not. Then we can say, in addition to above, building practice books were written, a lot of online engineering activities involving contracting, quality and coordination, designs issues being deliberated. A response to point number 1 is given now. This is about certain arbitration cases, you can say, where I used abstract concept. That. So that's why I say close this now. So we come back here, and also you can say I'll discuss all this CV issues later on. And now we are here to look. Okay, you can say close this. Maybe I have to by 2:30. I think. Let me a few minutes over. And before that, I like to show you my CV also. It's possible. Let me say, if I can, just for information. Maybe you are not interested, but if you're interested, you can see here my CV, and that is March 2020 photo, but this is not no problem. 14 December 2021. I can show it. I will see that. Let's say in this case, if I here, so let's take. I'll give this. I don't know. Is that detailed? So this is my CV, you can see. So just for reference it is, and not going to read it, just for indication it is CV. I'll discuss next time. What does it mean? How long it is? So I show it to you. I close it now, and I say. Now, what's my point of view here? It's different. I can start. We have gone through today with specifications of. Let me browse also this cement file. This is, of course, I will take up later on this one. I'll go back to his page. I think 60 around it is. So it is 60 something. We'll discuss this later on. And coordination engineering file that I said, quality file. So what we was discussing, quality file, engineers detailed definition must, and let us see what actually points, few points, not all, these are, and how we can handle this, how we can take care of this, and that's what we have to decide. Just few minutes, I think. Information, that's about engineers detailed deliberations must, which must be done. Information must be brought to those personnel who require it, and it must be provided in right time for right requirement and quite rightly duly coordinated. Dissemination of engineering information about quality requirements and how to transform using method statements. How to concentrate on construction methods. How to concentrate on construction methods, decision making, resolution to do right work for specified requirements. Methods can be designed and drawn, stated for designs for execution, for carrying out activities, as well as for rectifications, remedial for service. Methods means comprehensive methods, comprehensive, not selective one. No work be carried out without referring to method statements, which must contain safety, health and environment, and quality approach at every possible and convenient stage. What about contracts for construction? Should engineers know thoroughly? What about contract for designs, procurement and construction? Should engineers know thoroughly? Do we organize to design quality contract, or do we go per lines decided by others? Should we ignore power and impacts on works, quality, performance that contracts can attack on designs and prosecution? Do our engineers have interest in contract designs, drawings, activities, which always remains very complex and certainly impacts on contract performance and contract related disputes? Are our engineers those interested in design activities, not inclined to involve with construction activities? And if not, what are valid reasons? What's issue that engineers do not inclined to work in coordination activities that impact on quality of designs and quality of construction? Should we respect project contracts, or we should move without such contracts? What about major materials being concrete in structures? What about major materials that are considered often permanently included in structures and buildings, even everywhere on all projects? What about engineering materials being used to produce variations 100 parts goods in manufacturing? What is provision by government to force production and constructions be delivered with quality compliance? What can be certain reason that quality requirement is being ignored by nation? What reason does exist that engineers are not able to conduct required contributory roles towards quality domain? How can quality control and systems worked out for best organization in this regard? What should be required active role of engineers in all branches of engineering? What should be the role of actively performing workers to handle instructions in this regard? Is quality compliance requirement so difficult that professionals ignore it or they remain under pressure? Can people digest bad quality in goods, products, and in construction? What role of government in this regard? Should government not add? Yes. Can we people digest bad quality in goods, products, and in construction? What's the role of government in this regard? Should government not add its active role towards quality? What should be role of customer and consumer or end user in this relation? Should end user or minister or customer not be walked, not be awakened to know quality issues? So many questions are there. We'll continue these questions because these are very important questions and we have to answer. So we can say what should be customer, consumer, and user in this relation. Should end user, customer not be awakened to know quality requirements? We have to establish quality system and quality procedural approach while conducting designs, planning, and prosecution of execution of works. Who shall do it? Shall we keep it silent? Shall we keep silent, allow as it is, as it has been ongoing, or do something concrete, some concrete acts to encounter bad quality? Answer is that it's proper pragmatism. Answer is that it is pragmatism of engineers that would handle it. Not only civil engineering but also all other engineering operations must be oriented towards achieving quality objectives. It's not too late for development. It has to go on continuously basis. It's never too late for development to have to go on continuously, by which satisfaction must be obtained while performing engineering activities in organizations. Management that only talks of results without heavily or intensely weighing quality approach and sequential results cannot be relied upon. Should we apply only management principles or we should rely upon real organization methods where set goals, pertinent quality requirements are defined? Without achieving set quality requirements, no development can be sustainable and durable in long term. We have to keep it online and we have to move further. Meanwhile, it's only 2 hours 30 minutes. I'd like to take it today, and we'll see if we continue it next time. And that's important, of course. And we have to see that. This is my, again I say, Suraj_engineer at yahoo.co.uk. You can write to me and you can see the certification, quality file, coordination file, and we will discuss again phase 6 GRE. So I can see now you can close it rightly. Thank you very much.